Howdy, my name is John. I'm with the Astro Deep group, and this is our planet formation demo. So inside this acrylic disc on top of a rotating turntable, we have a bunch of different materials. We have water, oil, plastic pellets, and aquarium gravel. And the important thing about these materials is they all have very different densities. We also have a backlight here, and this kind of just helps to illustrate the effect of this demo better. So what we do with this demo is you can spin it faster and faster. And as you do this, over time, you will start to see different layers form with different densities. This is very similar to what happens in real planets. As planets form out of a protoplanetary disk, much like the Earth did in the early solar system, we start to see something called gravitational differentiation, which is where all of the different layers of the planet have different densities. And the reason for this is, as all the materials are pulled together based on gravity, the densest materials like iron and nickel will sink to the core of the Earth, while other materials like silicates and rocks that are a little bit lighter will rise to the crust. And then outside of that, you have the atmosphere as well, which is the lightest layer of the Earth. If we stop this disk very suddenly, you'll see all of the materials sort of mix back together into one homogeneous layer. Now there is one small caveat with this demo. Obviously on such a small scale we can't really produce the effect of gravity, so if you were watching closely, you might have noticed a small difference between the layers in the acrylic disc and the layers of real planets. Planets form under gravity, which is a radial force, or a force that acts in the direction of the planet's radius. And it pulls everything towards the center of the planet, so the densest materials will sink to the core. But in our demonstration, the heavier gravel flies to the outside, while the lightest materials, the plastic pellets, are pushed to the inside. And that's because when we spin the disk, we are creating a centrifugal force, much like how a centrifuge works. This is also a radial force, but it acts in the opposite direction and pushes all the material away from the center of the disk. But the key concept here is that we have a body of materials with different densities being acted on by a radial force. And so in both cases, we see the formation of a density gradient with several different layers of materials. Hope you enjoyed this demo, and thanks so much for watching.